Okay. Steganography, the art of hidden writing. On Tuesday, we went over PowerPoint on this and talked about what steganography is, steg analysis, some of the tools available. There is in the lab folder a zip file you can be downloading while I'm talking about this. It's in the lab folder for week 7. I believe it's a link that says download files or files needed, I believe. But basically at the end of this lab, what you will do is be able to hide and retrieve data in a bitmap image using a steganography program written in Windows 32-bit platform. Information, you'll utilize a program called Hide and Picture version 2.1 to hide and retrieve data in a bitmap graphic. Preparation, just need to download the zip file and follow instructions. You'll complete the reading here on the handout. Paper for notes, that's just as you're going along, you'll jot down maybe at the end here, we'll go over it, some information. All you need, this should work for Windows XP and all the way to 7. I've worked it on 7 before. There's a website for the program from the developer. It's not going to take 60 minutes, but let's go ahead and read about, I like this definition they have in here, the little story of steganography. It says the word steganography literally means covered writing, as derived from the Greek. It includes a vast array of methods of secret communication that conceal the very existence of the message. Throughout history, a multitude of methods of variation have been used to hide information. Today, with computers everywhere and access to a global network like the internet, these methods have gone digital. Steganography has been used since ancient Greece, extensively during World War II, and still exists today. Here's a message. We'll read a message in a second, but it says here on February 5th, 2001, USA Today reported that the United States FBI approved Osama bin Laden and his associates were hiding maps, photographs, and terrorist targets and instruction activities in web pages on the internet using steganography techniques. Example, here is a message sent by a German spy in World War II. The message says, apparently neutrals protest is thoroughly discounted and ignored. Isman hard hit. Blockade issue affects pretext for embargo on byproducts, ejecting suets and vegetable oils. If you take the second letter in each word, the message says, Pershing sales from NY June 1. And that was a really extracted fact that steganography, a form of steganography, was used. Software, we looked at some Tuesday. There's tons of them out there available, both Windows, Mac, PC, Linux, mostly freeware. So here's how it works. You'll, in that zip file, you're going to have a number of files, one of them being a bitmap picture file. It's simply a series of numbers representing color intensities, one color in each pixel of the picture. What hiding a picture does is it hides a file inside a picture by placing its bits in the least significant bits of each color in a picture. The least significant bits are LSB being the rightmost bit of the byte, the lowest binary value of 0 or 1, therefore it's the least significant. So suppose your picture has this data in it. The 253, 2, 195, 54, 69, 191, and 56. That'd be representing the color pixel possibly. The binary value of that would be that number below of all those ones and zeros. To hide character 109, the least significant bit of each byte would be replaced by a bit of the character. And then the result will be that binary, which it's easier to see the difference by reading the decimal version. So notice 200 is the same, 53 is the same, 2 is changed to 3, 195 is changed to 194, 54 is changed to 55, 69 is the same, 191 is changed to 190, and 56 is changed to 57. So you notice it's the last number in a digit, a decimal digit. It's also the last in the binary. We'll look at a couple sets here on the binary. On the first set of the binary, it should be the same. Second set of the binary, you've got, let's see here. Let me pull my little pencil out there. The second set of the binary should be different. It's going to be the third set. It's going to be the third set. Third set should be different. And also the fourth set and fifth set. Third, fourth, and fifth. Sixth is okay. Seventh is different. And 8 is different. Okay? And so the difference between the new value and the old is, let's go to the, oop, just want to select, there we go. Oh, done. The difference between the new value and the old one is very small. So difficult, if not impossible, for the human eye to identify any difference from the original picture, because it's just taking 1 bit out of a byte. If the hidden file is larger, though, as I mentioned Tuesday, it is maybe necessary to modify more than a single bit from each of the bytes, which can then make a difference. So step 1, what you guys are going to do in just a second, you will open up and verify that you've got the bitmap. You should have on step 2 a text file that says 8 test.txt. The step 3, which is the executable, I'll show you on my computer what that looks like in just a second. You're going to open that up, click on File, open the picture. Then you will hide the file in the picture. Step 5, you're going to select some options, which is a password and encryption. I believe you're going to select the blowfish encryption for it. Then you'll do a Save As. Verify the image quality. Retrieve the hidden data. You will be prompted for the password. Then once you put the password in, it's going to actually prompt you to save it somewhere. Then the next few steps is verifying the hidden data. And step 11 is the analysis of the data, where you're taking and comparing the original file with the modified file. The original files on step 11 are the steganorg.bitmap and the test.txt. The modified is a Stegan hidden and the test retrieved. Okay? You're going to determine a couple things. Degradation of images first. You'll look at that on the screen. And also notice if there's any property changes on the text. Okay? So let me go ahead and go to the computer here, and you guys should have that downloaded now, right? All right, cool. All right, so I have mine downloaded to my desktop here, and I'm going to go ahead and extract it. Just do an extract all. I thought I did. Well, I did. I had it in my downloads folder. Okay, I'm going to move mine to my desktop. You might do the same if you haven't already done so. Move that steg file to your desktop. Okay. So I'm going to right-click on that zip file. I'm going to extract all. There's my 6 steg. Open that up. Open that up. There's your original bitmap, your original text file. If you right-click on this 8HIP21, extract that one. The executable's in here, and it's this one right here with this icon, WinHIP_EN. You double-click on that. That is the extent of the size of the app. It's very small. And you take, and basically you're going to start here in step number 1. All right? There are some areas in here you have to fill out. Towards the end, if you'll forward fast real quick on your handout, then I'll let you fly on this real quick. on the analysis part, you're going to compare the sizes, and it says there is a question, is there a difference in size? You're going to compare the file size of the two texts. Is there a difference in file size there? So size of the image you're going to compare, and the size of the text you're going to compare. Step 12, hiding executable. I tell you to go out to the C Windows directory and hide Notepad in your image. You'll need to rename things differently, but you can, I think I'd just name them something different than what it was before for the image file, and also for the, it used to actually be just for the image file this time. Once you hide the Notepad in there, then see if there's any degradation of the original image and the modified image with Notepad hidden. And then see if you can launch Notepad once you extract it. Then we'll have a summary discussion and be done. So go for it, and I'll walk around and see if you need any help. Start with step 1. I'm not going to. Nope, not going to. There we go. That's the image you're going to use and the text file you're going to use. Okay? How are we doing over here?
Start from step 1.
Yeah, step 1. What you want? Verify your data files. You're going to open up the 8 Steganography bitmap with your image viewer, which is any image viewer you can use for that. Yeah, you guys can use Paint if you want to, just to make sure it looks just like that. Basically, you're just verifying the text file is a text file, the image file is an image file, and then begin with step 3 on opening the file in the picture. How's it going over here? All right. How are we doing over here, sir? How you doing over here? Do what?
I can't tell.
No, you probably, even if you blow them up, you can blow them up to like 800% on both images, and on the text file, you're probably not going to tell a difference. But now, when you do the Notepad one, you might tell a little difference on that one. How you guys doing over here?
Put an image in an image instead of Notepad.
Do what now?
If I put an image in an image instead of Notepad.
Well, the only benefit of doing Notepad will be it's larger. It's quite a bit larger, and it'll help see if there's any degradation. Because I don't remember the size of Notepad, but it's creeping up there to the size of that original bitmap, if I'm not mistaken.
The image is about 15% of the original size.
15%, yeah, that sounds about right. And you guys should be able to find, when you get to the Notepad part, it should be in the C Windows directory. When you get to step 12,
Yeah, I'm there.
C Windows directory, the C drive Windows folder.
Oh, Windows, okay. My bad.
I'm going to call mine 8 Stegan Notepad, so I'll know it's the modified Notepad version. The other thing you might make note of, you'll notice on the overhead when I did a save as, it does not put the .bitmap on the type, so if you forget to type it in, it will be no extension, and you'll have to manually type it in later, which you can do if you want to, or you can type it in right here where I'm at, just put a .bmp for bitmap, You should be okay. Same thing with the notepad. If you look on the overhead, you'll notice when I extract the notepad document or executable, no extensions. You have to put in a .exe on the end of that to correctly extract it or for it to run. Yeah. I think the program I like to use is just plain old-fashioned Paint to compare. You'll have to probably do like a file open with to get Paint to open it up easily.
What would they look like if you cloned them, like Photoshop, like really blew them up?
Do what now?
If you threw them in Photoshop, like really blew them up?
Yeah, the high should go up here is 800, which is actually pretty good. You can see a lot in 800% in Paint. It's still going to be difficult though, however you look at it. Oh, pretty good to me. Not much different, no difference at all. Okay, another one. Okay, that's 222.
Can you hide more than one in one photo?
No. You could zip something together, but you could zip something together and hide it that way. Zip the files together. Trying to find one here. So Lil. It is, isn't it?
Yeah.
Okay. Let's see. Notepad, I think, is like 78 KBs. This one I hid was 101, so we'll see if this ain't different. 101 kilobytes.
There's very few differences that you can, there's differences you can see in the white is what I found.
Yeah.
It's actually way easier to see over in the white before a 600%. And look at the white and red on the right side, and it's really simple to see. It's pretty obvious. And this thing can't work with other picture formats.
It's a bitmap only. Opening in bitmaps. But you can hide whatever you want to in it. Hide in picture file. Bitmap only.
Are there programs that can do other file types?
Oh yeah, we went over.
JPEG.
Oh yeah, JPEG, GIF, you name it, they can do.
Is it just that, I mean, when you're trying to hide something on the same side as the file, the picture doesn't look different even blown up?
No, this is 101 KBs. The one I have here on the top, or on the bottom is 101. Because the original file is what, 222 or something? 222. Now the one thing, if you get up, if you creep up, like I said, high, close to that original, you can definitely see degradation.
Now,
Because if you guys try to find a file that's close to that, you can definitely get degradation. The higher up you get, the more degradation you're going to get. Now, going beyond it, like this 700 KB, 719. See, it's too big. You can't exceed that.
so it's got limits on the
Yeah, right. It notices you're not going to go larger, but you can go underneath it.
Put it into a 1K.
Yeah, you can go underneath it. There's like a 146.
It just kills the data too much.
Here's a 146 bit PDF file, which is creeping up there a little bit more. I'm going to take this to, let's see, normal size.
Now you can take a file, encrypt the file, and then put it into a Stego too, right?
Oh yeah, definitely. Yeah, you could definitely do that.
Crazy. 1024 encryption on a file and drop it to disk.
Now this one down here, I've noticed,
Ridiculously sized.
right in here, I noticed a little difference on pen. See if I can get a different color. It's like my color. Okay, how's everybody doing? How's everybody doing? Okay?
Is the file size supposed to change at all?
No?
No?
Oh, no, the file size won't change.
That's the point.
That's the whole point of it.
The LSBs out of it, and putting the data
Yeah.
back to the LSB.
No, and the only thing, it'll let you go up as high as you can, close to that file size. In fact, I think the logic is it'll let you go up to equal the file size of that bitmap. It won't let you exceed it, but it'll let you go up to equal. But we'll talk about it here in a second. You can see the degradation on that G there a little bit on the bottom one. That's the one that's got the, what is it? What size is that on that one? I can't remember.
Pretty much the larger the file you want to hide.
Yeah, the larger the file.
The larger the bitmap has to be to accommodate it.
That one was 146. 146 KB on this bottom one. So you can definitely see degradation just by looking at the bottom one. It's more granulated, more pixelated. Just the picture is just not blown up anymore. You can see like down in here, this area here to the black. The blackness isn't true black.
Actually, that area on the T was pretty bad too.
Do what now?
T's, lines.
Oh yeah. I mean, you can actually see the boxes more so here show up. The pixelated boxes show up. That's actually taking up more. I'm guessing I had to take more than one least significant bit. Like maybe two of the least significant bits possibly to get this much degradation. So, but again, at 100%, both viewing these at 100% on a website, nope, probably not going to be able to tell much difference. Top and bottom, if you didn't know the original. Granted, I do see this one just seems a little grainier, but besides that, and also the text here is a little fuzzier. Besides that, I can't really tell the difference. So, how we doing over here? How we doing over here? You can't find what?
My tests and the retrieve file.
You have to be in the program.
Okay.
You have to open the, is this the hidden one?
Yeah.
And then you retrieve file from the image, type in your password. It looks like you didn't hide it in that picture file, so what you'll have to do is open that back up, the original. Okay, go and type in a password twice. Click OK. Gotta be the same password on the top and bottom. There you go. Now go to the file menu. Actually, it should be in this one here. I don't need that one. Well, you had two of them open, it looks like, maybe. Okay, now go put in your password. Okay, now you want to go ahead and do a image. Save picture as, and then here's, click on the hidden one, the one that says hidden. You already named it. Click save, click yes, then click the retrieve button. Okay, type in your password. There you go. And before you hit save, you need to go ahead and put a dot test. I believe it's test hidden, I believe, right? Yeah, 8 test hidden. Is that right? Or test retrieved .txt. You have to type that in. Yeah, txt. That's the extension. And click save. All right, there you go. Now go ahead and close out of everything right now. Close that, and then go ahead and open up your original or the retrieved one. Good, and then close that out. The one you just opened, the test retrieved. And then open up the original. Nope, that's the hit, that one right there. There you go, it should be the same file. And then look to see if they're the same file size. Go and close that. Is your images the same file size, the original? Now you'll have to go up to detail view on your menu here. View details. See if they're the same size on the original, which is 222, and there's your modified 222. Okay? And then the last one was hiding Notepad into your, so basically you have to go back into HP21, open up the original org, Stegan.org, and then go ahead and do an image file. You're going to hide a file. Yep. Browse out to the C drive in the Windows directory to get Notepad. Yep.
So, what are we looking for here? The file, I mean, the size is the same, right?
Yep. Should be the same. But you would think they'd be different, right?
Right.
Yeah, but they're going to be the same.
But these two are exactly the same.
Yeah. They're the same image, but one has a file hidden in it, right?
Mm-hmm. Yeah, this one's hidden, this one.
Right. You're comparing the two images to make sure they're size-wise the same, and also viewing-wise, like 100%, like I have on the overhead. Do they view at 100% the same? And you can blow them up both. But we'll talk about later about that size-wise. But the more you creep towards the size of the bitmap, the more degradation you're going to get on that modified image. Okay? But as long as you stay under the size of the bitmap, file size, at normal 100%, you're not going to see any degradation hardly at all on the image.
Okay.
Okay? And so just answer the questions. Are they the same size? Yes. Do they look the same? Yes. How are we doing over here?
For the noticeable differences, this is the one with the file on it.
Yeah, what size is that file?
This is at 600.
No, what size is the file size on the one you made?
21.
220. Okay, that's pretty close. Yeah. Yeah, you're definitely going to see. Now, go ahead and do me a favor. Do 100% on both. I want to see the 100% view on both of that. Just normal size. Yeah, normal size. I don't really see it at 100, do you? I don't. Not from here anyway. It's a little lighter, maybe.
Both 100, right?
Yeah, you're both 100%. This is a modified. That's the.
Yes, it's overlapping, that's why. The only thing I can see noticeable difference at 100 is that this right here looks like a different color.
Mhm.
Lighter, and that looks like
Yeah.
darker in the back.
But very, 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 and that's only one KB lesser than the original bitmap. Wow, crazy. Huh? Yeah, his was 222. The bitmap was the file size was what, 221, right? Your bitmap's 222, and at 100%, you can't even tell the difference. Cannot even tell the difference. If you didn't know the original, you wouldn't be able to tell any difference. Okay, here in just a second, well, there's a few still wrapping up. We're going to go ahead and go over the summary discussion and show you the example I have on the overhead. Some of you had pushed the limit, got it right below the file size of the image, and you could definitely see some degradation as you blew it up.
How is it that when you retain, that when you pretty much push it to 90+%,
How you do what now?
you pretty much have a file in there that's 90+% of the original file size, how is it staying the same and giving you much greater than 50% of the original image in most cases?
Oh yeah, because it's actually it's using that least significant bit logic, right? But what it's doing is starting on the least significant bit on a binary. It goes from it has eight places. So it first starts on the right, and then if it needs more, it keeps going this way. but the bulk of the image pixels are going to be found in like the first 5 or 6 binary bits. So as long as they're not taking up, you know, and they've got a lot of data to deal with, you know, a lot of bits to eat up, basically.
But even with that, I mean, with, you know, 8 spots, zeros and ones, if you're replacing, you know, 7 out of 8 of them,
Mhm.
how on earth is the image staying?
Well, it's replacing it with actually valid data, so it's changing the color just a little bit, but not a lot. So it's actually it can only change it with a 0 or a 1,
Yeah.
and that's it. And so it's either going to make it a little darker or a little lighter, or a little bit more pixelated. But that's about it. It's still going to have like color, but not going to be the original.
Pretty much as long as it, even with that first bit, I mean, that right there, if you look at that in terms of translating that into hexadecimal or 255, 255, 255.
Yeah.
How can that one first bit make sure that it stays a shade of green, something close to black?
Like I said, that's why it doesn't let you exceed the file size, because if it couldn't do it, wouldn't work if it exceeded the file size. But if it goes up like right up to the file size, you're going to use, it's probably not going to use more than 4 out of the 8 bits. Each one of the bytes is going to have 4 reserved for the original color. So that's why a lot of times you'll see degradation, that like on his, it was a little bit lighter on 100%, but still,
But
you know, still the original color.
The image that you're putting in isn't being degraded.
The what now?
The image that you're hiding isn't being degraded, or whatever you're hiding is not being degraded.
No, that's not being degraded. It's just the bitmap's being degraded. The file's not being degraded. The bitmap's being degraded. Because what it's doing is actually taking the file, splitting it up into millions bits of pieces, and putting it in these least significant bits. Then when it extracts it, it puts it all back together. So yeah, it is breaking it up initially, but it's not degrading, just breaking it up within the file.
It just seems so.
It's crazy. It is.
I mean, if you
Yeah.
try in Photoshop to save an image with a size constraint of half of what the original one,
Oh yeah, you're right.
I mean,
Mhm.
this degradation, nothing compared to that.
No.
So,
Mm-mm. No, a lot of it has to do with
do you see where my confusion there is?
definitely, it has to do with the LSBs, the least significant bit, because in what you're talking about, it's using Photoshop to do all you're talking about.
Yeah.
What we're doing is using a program that's designed only to fit a file, whatever file type, into the least significant bits. That's all it's designed to do. Whereas image software like Photoshop,
Actually, this makes sense now because a bit is a finite size.
yeah,
So-
exactly, yeah.
Okay, it just clicked.
Yeah, and so there is limits to it, but literally you can put up right to, or some of you did, right up to the file size, and really at 100% see hardly any degradation whatsoever.
That makes sense because if you're doing something like Photoshop, you're actually chopping out the number of bits that you have.
Exactly, right. You are modifying that. Yes.
So you can email these files to someone.
Uh-huh. Yeah, you could email your file to him.
And then after, when he retrieved the file, he has to have the same program and.
He'd have to have the hide and picture program right, type in the password, and he could retrieve that file from that picture.
And he needs to know the password.
You need to know the password, that's all you need to know, yeah. Exactly, yeah. Okay, let's go ahead and talk about it real quick. On the lab itself, before we get to the questions, let me see. I know you hit 221. Anybody get higher than that on the file size that you hid in the picture? At 221, at 100%, if you guys want, you still have it up on your screen. You might, before you leave, just kind of look at it real quick. At 221, at 100%, I couldn't tell any difference. He could tell a little difference on the one that was modified towards the upper part of the image. And then after a while, it's because you're looking at the image. You're looking for you're looking for something. You know what to look for, right? But if you didn't know the original file, you wouldn't be able to see. And this one here, I think that I had up here was 111 or something like that. I can't remember. And that's at 100%. I believe when it was blown up to 400%, you saw some degradation. I believe at 400%. Let me see here. I think that was right on this one. yeah, on the G. But then also you'll notice that look at all the pixelated areas here compared to the original. It's just a lot grayscalier than the top one, this modified one. But again, you're not going to usually blow them up. If this picture's on a website, this bottom picture's on a website at 100%, you're not going to be able to tell the difference. Okay? So did you find any, on step 11 or step 10, were the contents of both the text file and the image files the same size? The same size. Anybody find any differences?
The text file and the image file?
The text file versus text file, image file versus image file. Same? Okay. And the reason for that, as we've already discussed a little bit here, is it replaces up to the file size, a least significant bit of that, pushes basically that file size into the image, replacing the least significant bit of each one of the bytes. Then it had you look at the file size of both. We talked about that. Hiding executable, that was a no-brainer. Didn't show any, I didn't see any difference on the Notepad up to 800% actually. I didn't see any degradation. I think Notepad's only like 77 KBs or something. So, you know, you can hide not just pictures or files in here, but executables. You could hide music files, video files, whatever, into these, you know, like a, I don't know, just thinking like a Mission Impossible thing. You know, a video file, it gives you a minute video file. It might be, I don't know, 2 megabytes or 3 megabytes in size into a, you know, 3 megabyte bitmap, and open that up to view your next assignment, you know, something like that, you know. Something crazy like that. Have a Facebook page you go to and see your next assignment. That's actually pretty cool to do something like that. Yeah, that's actually not a bad idea, man. That's a great idea. That's right. You have 3 days to figure this out. The clock is ticking. Students jumping out the windows. Oh, man. So what this lab proves is that steganography uses a least significant bit of an image and replaces it with hidden data. Since the original text hidden was 500 KB or 50 KB, and it was hidden in a 219 KB size, it's actually 221, the image file should have grown by 50K, but since we removed the LSBs and replaced it with our hidden data, we're able to basically hide that 50K inside the image file without affecting the file size. A couple more websites there. And on Tuesday, we mentioned on the PowerPoint that's in the folder, by the way, for this week, week 7, a couple links in there give you a lot of good resources as far as other Stego type of apps, like MP3 Stego, Movie Stego, other image file type Stegos, like, you know, PNG, JPEG, that's a popular one. Because JPEGs generally you will find on websites. Bitmaps you generally don't find on websites. But JPEGs you definitely find on websites all the time. PNGs are quite large files that you'll find on websites that, you know, they're basically the best quality image you can put on a website. And they're a little larger generally. And PNGs you can actually fit a lot of data into. And so, what do you guys think of this lab? Pretty cool, right? Yeah, you see Mission Impossible. Dun, 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 dun. Yeah, that would actually be a really cool thing to do with this lesson, I'm thinking. You guys got me going. Some type of Facebook page, I'm thinking, with multiple images on it, but not all of them have hidden data in it. And finding the right data to get some type of, you know, prize at the end or something. Yeah, extra credit, yeah. Do what now?
You gotta throw like an Enigma machine in there so they have to figure out the password.
Yeah, oh, definitely, yeah, you're not getting the password. You got to figure that one out. You got to figure that one out, yeah. Yeah, we'll have to show you to do something like that.
College scavenger hunt, it starts globally, like something that anyone can do, like the Amazing Race, and then it gets down into this kind of stuff, and so other students have to start running it in order to win the iPad.
Yeah, or yeah, you go from like one image and it gives you clues to go to another page or something like that. Oh yeah, it'd be crazy, man. Yeah, I have to do that over the Christmas break or something. So.
I wonder if that's how a virus hit under the file somewhere.
Do what now?
I wonder if that's how a virus is in the file.
No, no. This type of technology is generally going to be used for what purpose you think? Just right off the top of your head. Boom. I mean, right? It's for confidential data in Facebook pages like we mentioned, which is really popular now. Anybody can set one up for free. Flickr accounts, exactly. Twitter can actually post pictures on there as well. What's the other real popular image app? No, Instagram. Instagram's a real popular one. That was just bought by Facebook, right, recently, I think. But yeah, you're right. Any type of image free website can be used by this technology. And so, yeah, mainly for espionage, not so much for viruses, really. But now I have seen in peer-to-peer sites, students have come to me with their computer and had a virus that was in an MP3, purposely embedded by the creator of that song or the record company or whatever, embedded a type of malware or something in an MP3, just for people to shouldn't be downloading anyway. Pirated stuff, do junky stuff to their computer. So that was actually embedded in a file, but it didn't. That wasn't hide in anything. That was actually a malware that when they ran the MP3, there was also a process that ran that installed malware from that MP3. But that would be totally separate from what we're doing tonight. But it's along what you're saying though, is that you can embed anything as a carrier. Anything can be a carrier basically, whether it be a picture file, MP3, executable. And you can hide in it what's called scripting or automated function, automated programming, to where when you open up that app or open up that app that opens up that program, like say open up iTunes to open up the MP3, it fires and triggers a malware device. But what we're doing here tonight more than likely would be used for evil, to sell corporate data, espionage. But I had a student actually have a good idea last semester, said, to see if you guys have any good ideas with this. Using it for good was hiding like corporate patents inside of images, and then securing them in a location. But if anybody ever got a hold of them, they would just think they're company pictures and not really think of anything twice about it.
I was going to say, maybe hiding the ownership of
Yeah,
file.
well, you know how people have lost their laptops?
You stole my file. No, I didn't.
You know how people,
Okay, let me look at it.
you know how folks go in the sales and lose their laptops and lose all the data of the company possibly, like social security numbers, whatever? Well, you could use this technology actually. Have the hide and picture file on a USB drive that's always in the guy's pocket or the girl's pocket, the salesperson's pocket. But all the files on the laptop would be in picture format, in a picture folder, and named like maybe numbers or whatever you want to do it to make it don't look fishy or whatever. Like Sally Joe 124, whatever, the date and time or whatever, to make it look like a real picture, right? But it's actually corporate files, company files, customer files in picture format. That might actually be pretty smart to do something like that. Because if you did lose a laptop or something happened, the only way a person could open up those files would be if they had the original file, program that created it, hid that data in that picture, and knew the password and the algorithm used to extract it. Okay? And most likely hackers, if they found, or somebody that found this laptop would just find pictures and go, format, yeah. Who cares? A million pictures? Who cares? This guy's stupid. Yeah. Yeah, the same picture morphed, the face of the kids and the family just kind of morphed a little bit, each one of them. Like, it's the same pictures over and over again. That's weird. Yeah, exactly. Now, that might actually be a pretty smart way to do it. Anybody have another thought of ways to use this for good in the workplace? Something like that same vein or same idea? I don't know. Anybody think of anything?
You could almost use it as My Life in a Box, the way the military does.
Yeah. Yeah.
It's run and it's got your whole life. But if you save an image, say, to the cloud, as long as you can access the cloud from anywhere,
Well, that's a good idea.
then you
Like a
have your life
Dropbox or
in the
whatever.
cloud instead of in the box.
Open ID.
That's a smart idea. That's a good one. That's actually a really good idea. Because you can actually hide all of your, pertinent, sensitive information in that on a cloud location.
Open documents and zip it up. I mean, you, your kids, anything.
Smart idea. I like it. I like it.
You can access it from anywhere.
Can access it from anywhere.
Someone gets a hold of it, but you don't
It's
unless.
just a picture of my dog. Great.
Yeah.
Awesome.
Yeah.
Cute dog. Moving on.
Yeah. That's cool. I like that idea. That's a great one. I'll share that next semester. So, all right. Well.
Are you gonna show the ugly dog instead?
That'd be interesting. Overlay for your Dropbox or your Google Drive, where the folder, the network folder, becomes invisible, replaced with another one that automatically runs an encryption algorithm and files in it, so that you can see the real files before they go back. They're re-encrypted with some steganographic technique.
Well, the lab we're going to be doing I think in a week or two is kind of does what you're talking about.
So it's like instantly everything going outside is mundane, and everything coming in is
Right,
you
it's-
want before you see it.
That's a good idea. Well, do me a favor before you guys leave tonight, if you haven't already done so. In the lab folder, submit your name since I'm not collecting anything from you, if you haven't already done so. And then you're free to go. Have a great weekend, and see everybody next week.
You're still doing makeup for last week's lab?
Yeah, that's right. Well, we got internet security. Yeah, internet security, internet IE security. I can show you how to do that. Who else needed to do that? Okay, you want to come up here to the first row real quick?
That'd be easier than folder loose encryption or hidden TrueCrypt.
Yeah, that's what TrueCrypt's the lab I was talking about. TrueCrypt's the lab I'm talking about. That we're going to be doing that.
That'll be fun. I have that on my laptop.
Look ahead in a few weeks. It's in there. So
Well, heck, I've got full encryption and then I've got hidden partitions.
yeah, well you'll like this lab, yeah, because we go over all TrueCrypt stuff. Huh? Yeah, come up front. I'll have you guys actually do it together, if you don't mind, and then we'll just say you're done. Okay, the whole purpose of this basically, we'll skip the first part, which is basically looking at security on IE to determine like high, medium, and low, what it does to your settings to let things in or let things out, basically. So go ahead and go in IE real quick, and if you go up to the Tools menu and go down, Internet Options, and we want to go to Security tab, and then we're going to go to the Custom Level, and then we'll start with the drop-down where it says Reset To, go to High, and then click Reset, click Yes. Now, you'll notice when you go to High, immediately this top stuff is everything, a lot of stuff's disabled, like .NET Framework, going on to the .NET Framework components, runtime, things running in the browser are disabled, ActiveX is disabled, pretty much everything's disabled coming in, downloading unsigned ActiveX. Now if you switch it to the next one, which is medium,
Medium or medium high?
yeah, medium high, the middle one, you'll notice, okay, right off the bat, you start noticing some stuff's enabled here. It's a little bit lesser security, but people can function and get their jobs done and not have to, it's not going to hurt anything on your computer. And then go to the last one, which is the medium one. And the main one I'll focus on this one. If you scroll all the way towards the bottom, it's the download file area. I think it might be in the middle. File download. Okay, so file download right now is enabled, but you could actually, and again, this is browser specific, so if you had Firefox and Chrome, this wouldn't be the same. But if you went ahead and clicked on download disable, go ahead and click on that radio button. Click OK. Click yes. Click apply. Click OK again. Now go to download.com, and we're going to try to download anything from download.com, any type of file. Yeah, that's fine. There we go. Okay. Now, one of the things you can do is and most users aren't going to know how to do what we just did, but you can with, we went over in class, GP Edit, which if you go to the Start button on your computer and go to the Run command and type in gpedit.msc,
Space.
nope, just all one word, gpedit.msc. On the left side, where it has user configuration, Windows settings folder, expand that one, I believe. Internet Explorer and security. Now, we have these kind of locked down here, but on most computers are going to have the ability to block folks from getting to options altogether in this group policy editor. And so you can basically, if you click on, like, say, programs, click on programs right below security there, and double click on that. What this is basically, it says here, it gives you in each one of these you would click on, it gives you a description of what it is. It says you can import the current program settings. The program settings specify which programs Windows automatically uses for each internet service. You can default program for each of the following internet services, like what do you want to use for HTML editor, email. So basically what it's saying is you can create a customized file and bring it in here. And it can do a number of things. It can lock people out to where only you can get in as an admin, which is helpful. So go ahead and hit the cancel one there. Now go to, I think it is administrative templates on the bottom part. And Windows Components again. Windows Media File. Click on the Windows Media Player folder under Windows Components. Yeah. And see where it says, let's see, user, I think it's user interface. Double click on that. Hide security tab. Double click on that and enable that. Okay. Now before we hit apply, go ahead and just leave this here. Go to the start button on your computer. We're going to go to Windows Media Player right there. Should be the first one there. Okay. Now go to Tools, Options, and we should see Security in there. You see it? Go and click on Security. Now go back to your GP Edit screen and double click on that Hide Security tab. It should bring that thing back up.
Where'd it go? There it is. No?
There it is. Okay, now go ahead and hit Apply. Click OK. Keep the screen here. Go back to Windows Media Player now. And you'll have to hit Cancel on this screen. Now go to Tools, Options. Should be gone. Okay? That's just a little, window into what GP Edit can do. Now go back to GP Edit, and we're going to disable that, or not configure it, apply it. And I just told them last week, basically, anytime you're in GP Edit, and you guys can do much more in GP Edit than you can do here, okay? Anytime you're playing with GP Edit, just make sure you leave the GP Edit open at all times while you're playing with it, and do what we just did. See what you want to do, right? See if it works or it doesn't work, but then always go back to GP Edit to change it back to not configured. All right, that's what I recommend doing. Last thing we do is go to, close out of this, go back to Internet Explorer, go into Tools again, and Security. We're going to go back to Security. This time we're going to go to Restricted Sites, all the way to the right. Double click on that, go to Sites, and download.com's already in there. Click on that, and add it, and go ahead and we also want to put in there, I believe, the asterisk key. Yeah, asterisk key .cnet.com. That way it's going to get everything in the asterisk domain. Okay, click add on that. Okay, click close. Now let's go back to the, we need to go back to the custom level and make available the downloads, because I don't think we put that back, did we? It's still disabled. There you go. I'm going to click OK. Yes. OK. All right. Now, go ahead and close the browser out altogether. Reopen it again. And then this time we're going to go download.com. And try to download something again.
Now, if I blocked it as a restricted site, why did it let me go?
Well, you're blocking activity on that site, not the whole site, just activity. Anything that could be malicious, like something downloading. So if you go ahead and hit that little eye there, the little eye, you notice how it kind of looks funky? Because it's blocking anything that could be malicious. In fact, if you scroll down the site real quick before we go to that eye, just scroll down. See how everything is just, it doesn't look good. It's blocking a whole bunch of stuff. But go ahead and double click on that eye. It'll tell you what it's blocked thus far. See, just by loading that site one time, not doing anything. See what all it's blocked? And so that's what it's going to do in a restricted site. And then if you were to try to download something, it would block it. It would show, it would block that information. So go ahead and hit the settings button. And then here you can actually tweak it even further to say, okay, I don't want to, allow whatever. I don't want to allow, a .text file, or I don't want to allow a .php file on this website, something like that. You can put whatever you want to on there. Okay, now let's go and go back to the security tab, go back to restricted sites. We're going to go to sites again and get rid of those 2 sites that are in there and remove them. Click close, apply, okay. Close that, close out the browser altogether, reopen it again just to make sure you can go to download.com again. And everything looks better, hopefully. There we go. Done. That was basically what we did. A lot slower, but we did. We'll give you the forward fast model. So that's basically what we did. We went over internet security, GP edit, and that's it. And granted, which I told them in the class, and it's still the case, most businesses still use IE as the main browser. And it's not going to change for a while. Okay, and especially with IE 9 that just came out, evidently that's gotten real good reviews from what I've heard. And and what it's competing against is Chrome, which has gotten rave reviews, but it's also got some bad reviews because it's kind of doesn't show some websites correctly, and it's got some weird stuff that happens with security. And so I think that's going to help 9 actually. And so, but in the business world, you're always going to see IE I'm going to say for as long as we're alive anyway. But that could change. It could change in the future, but with Microsoft going to 9 and then also Microsoft hitting the tablet with Windows 8, more than likely you're going to see Microsoft get better in their browser capabilities, I'm thinking. Because I didn't much like 7. 8, I liked 8. I've heard is a little bit better. I haven't played with it much personally, but 9 I heard is going to be really, really good. So that's it. Just submit the lab if you haven't already done so for last week in there, and then you are done.